Alright, this is lesson 13, factoring trinomials. We're continuing on what we learned yesterday. It's an extension of what we learned yesterday. So, I was just trying to get your attention. But we're going to work on problems that are a little bit harder. So specifically, you'll notice that today, when we're working out, you'll notice it'll be a little harder to find factors. It'll be bigger numbers, and it'll be a little bit. And then you're going to notice that there's going to be that fraction part that I said you have to simplify the fraction. That'll be the part that you'll have to pay attention to today. And you'll see it in my examples here. So, here are the steps for today. Same thing as yesterday. Remember step 3, we have to create an X box. An X box is as follows. You create an X with a line through it. And then you put A here, A times C at the top, and then B at the bottom. We're trying to put factors of whatever multiplies to be A times C, but adds up to B over here. Okay? Here we go, numbers 1 and 2. We got 5, x squared plus 8x minus 8. So we're watching right now, just watch. Okay? So the first thing I want to do is ask myself, is there a GCF? I'm looking at all of my coefficients here, 5, 18, and negative 8. There's nothing that really goes in them. 5's odd. Unfortunately, nothing goes into all three. So I know there isn't a GCF, and there's no x in this last term, so I can't use that. Okay? So what I need to do is now do an x box and attempt to see if there's any sort of factors I could factor out. So I'm going to create an x box like yesterday. Okay? So we're going to put a is here, 5 and 5, right? Yesterday, a was always what? 1, right? So today's going to be a little more interesting. Then we're going to do a times c. It's 5 times negative 8 is negative 40. And then b is 18. And I asked myself, what times what is equal to negative 40 but adds up to negative 18? Okay? Well, once I get good at this, I notice it's going to be 20 times negative 2, right? Because 20 times negative 2 is negative 40. 20 plus negative 2 is equal to positive 18. It's really important that we get the right signs here, because if you use negative 20... and positive 2, is negative 20 and positive 2 add up to positive 18? No. Okay, so it's really important that we use the right sign. So we're going to put 20 here. And we're putting negative 2 here. And then we box our fractions. We ask ourselves, can I simplify 5 over 20? Yes. What goes into both 5 over 20? 5. So it's going to be 1 over 4. That's one of the fractions. The other fraction, 5 over negative 2. I can't simplify that, so now I'm going to write my answer with these 1/4 and 5/2 as my coefficients for my problem. So I'm just going to write 2 parentheses. Okay. I look up here at where it says the first term, it says x squared, so I ask myself, what is the square root of x squared? It's x, so I'm going to put x here, and then I put my coefficients. We have 1 over 4, so I'm going to put 1, which is, we don't need 1 for x, and positive 4. And then I have 5x minus 2. And that's it. That's how you do number 1. Okay? Super easy, right? Yep?
So you don't need the 5x on the outside?
Nope. This 5x?
No.
Or at the beginning? Nope, it doesn't matter. Why doesn't it matter? What property did I say yesterday?
Oh.
Which property? Commutative property of multiplication. Okay? Okay, watch me do number 2 one more time. We have 36b squared minus 12b minus 8. Okay. So the first thing we want to do is create an X box. Or actually, the first thing we want to do is see if there are any common factors that go into all of these. Okay, GCF first. 36b squared minus 12b minus 8. I know 4 goes into all of them. Does 6 go into all of them? No. Does 8 go into all of them? No, just 4. So I'm going to take out a 4 first. So you got 4, open parentheses. 4 times what is 36b? 9b squared, right? Minus 3b. Minus 2. Okay? Then we're going to do an X box on the terms that are on the inside. We have a is 9. A times c is negative 18. B is negative 3. I asked myself, what times what is equal to? Negative 18, but adds up to negative 3. Well, I know negative 6 and positive 3 would work. Because negative 6 plus 3 is negative 3, right? So that would work. And not, just to make a proof of point again, don't use 6 and negative 3. Does 6 times negative 3 equal to 18? Negative 18, yeah, but 6 plus negative 3 is equal to positive 3, which is not our b in this case, so this would be the wrong one, okay? So we're going to use negative 6 and positive 3. We have two fractions. What goes into each of these? Well, 3 does, okay? 9 divided by 3 is 3. Negative 6 divided by 3 is negative 2. Can't simplify that anymore, so that's really what our coefficients will be. Same here, we got 3 over 1. Then we're going to go create a set of binomials showing the factored form of this, okay? And not forgetting the 4 in the front. So we got 3b minus 2 times 3b plus 1. And that's it. We're all done. Marks your answer. Right? Easy, right? Questions on numbers 1 or 2? Okay, cool. Today is Wednesday. Number 3. Okay, 3p squared minus 29p plus 56. Check with your neighbor first. Ask them, is there a GCF? Okay, so is there a GCF here? No, so we got 3p squared minus 29p plus 56. Okay, so now we have to do a little multiplication, right? So I'll start you off and then I'll have you finish it. Okay, so what's our a, everyone? 3. So we're putting 3 and 3 here. A times c. What's 3 times positive 56? What? 168. Okay. Now multiples of, or factors of 168 that up to negative 29. Okay, so when it gets hard like this, are we going to pick multiples like 1 times 168, 2 times 80? No, let's think about this a little more carefully. What numbers do you think would work in here? Okay, so we're starting. Let's start with the least 4, okay? So, and by the way, let's think about this also. Should my positive number in the pair of factors be, or a bigger number be positive or negative when we're adding these two together? What's that?
Positive. Higher, bigger number.
Higher, bigger number. Okay, good. So, well, now, the bigger number needs to be positive or negative? Negative. Okay, good. Okay, so I know that 4 goes into this, so I'm going to have a positive 4 times negative 42. Does that work? Yes or no? No. What about 5? Is 5 a factor that goes into here? No. What about 6? 6 works? Let's see if 6 works. We want to use negative 21, right? Now I got a question for you. Should I have used positive and negative? 2 negatives or 2 positives? 2 negatives, right? So when you're working this out, make sure you have the right signs, okay? Does negative 8 times negative 21 work? Yeah. What does it add up to? Negative 29, okay? So sometimes, on this example I want to show you, is you're going to have to think through it. These are, your factors are going to get more larger, so you're going to have to work through these problems. All right, finish up the problem for me. You're going to put negative 8, negative 21 here, and I want you to check these fractions, make sure that they are simplified before you give me your final answer. Ready, set, go. Good, so on this example, you have 3 going into each of these. We got 1 over negative 7. And I'm noticing some of you are like putting the 1 in the front. Let me just say, when you have a 1 as a coefficient, do we need to have a coefficient of 1 in front of letters? No, it's redundant, so we don't need that. So we're going to put 3p, using the right letter, 3p minus 8 times p minus 7. Okay? Number 4. before you start, is there a GCF? Ask your neighbor, is there a GCF for this one? Okay, good. 5 is your GCF, so we're going to open parentheses, 5. 5 times what is 45m squared? 9m squared. 5 times what is positive 135? $27. Five times what is 40? Okay, good. You got that one. So you're going to have to work these problems out if you're not getting it, right? We know that 5 times 30 is 150, so 135 is a little smaller, so it's 27, okay? Work this out for me, please. I'll give you 2 minutes. Okay, once you get here, ignore the 5. Don't worry about the 5. Now we just have to do an X box. Okay, so A is 9. Put 9 and 9 here, okay? Raise your hand if you got it wrong or you didn't get it. If you didn't get it, then I need you to copy me, okay? So fix your answer. A times C is 72. B is 27. What times what is equal to 72 but adds up to 27? What? 24 times 3. Okay? That's right. Because we know 25 times 3 is 75. Right? Raise your hand if it's hard for you to find the factors. Okay, so here's the trick with that. If you're not good at it, this is how you get good at it. Start with 1. 1 times what is 27? Or I mean 72. 1 times 72. What's 1 plus 72? 73. Is this the factor? No. Then we cross it out. Then we go with the next number, 2. 2 times what is 72? 36. Good. What's 2 plus 36? 38. Does that work as a factor? No, not for this problem. What about 3? Does 3 work? 3 times what is 72? 24. What's 3 plus 24? 27. That's what you're going to have to do. So all the people who just didn't raise their or just raised their hand, that's what you're going to have to do. And that really applies to all of you, because when there are problems that you can't do quickly, make a list. Okay? Anyways, continuing here. 9 over 24. Can I simplify 9 over 24? What goes into both of them? 3. So we got 3 over 8. What goes into 9 over 3? 3 as well. 3 over 1. Okay. Set of parentheses with a 5 in the front. Don't want to forget the 5. You got 3 m plus 8 all over 3m plus 1. Okay? And that's it. That's how you do what we're doing today, GCF and Xbox. I'm going to end there because for the most part, I feel like we have it. I think you just need to clean it up a little bit when you're doing your factors. So that concludes the lesson.